Hi guys, so today we're going to go over more techniques of differentiation or determining a derivative. So you've already seen how to determine a derivative using the difference quotient, and we're going to use another method today, which will be a shorter method. Some of you already saw the power rule in pre-cal, but we're going to start there. So techniques of differentiation, we're going to go over a few of them. Again, today will be the power rule. Just kind of a note, a few ways they may ask you for the derivative is f prime of x, dy over dx, which means the derivative of y with respect to x, because usually the functions are in terms of x, or the derivative of f of x. So just know that all of these mean the same thing. Now for the power rule, I know when you see the formula it looks a little weird, but just keep in mind that n is the power. So you're going to multiply the coefficient times the power and then subtract the power from 1. So that will be how we're going to apply the power rule. It's going to be easier, I guess, once we use the examples. So the first one, f of x equals 3x plus 5. We're going to start determining its derivative by taking f prime of x equals. So the first rule is we multiply the power times the coefficient. 3 times 5 is 15. And then we take 1 away from the power. So 5 minus 1 is 4. So that's pretty much the derivative. If you were to apply this function in the difference quotient, you would end up with the same derivative. So this is just for one term. You know, there's nothing being multiplied. There's no extra variables, nothing being added. So, you know, this is kind of the simplest type of problem you'll see. They can step it up a little bit for the power rule. So, for instance, g of x equals 1 over x to the 7th power. You may not use the power rule yet because x is in the denominator. So to start it off, we need to make sure that our exponent and its base is in the numerator. So x as well as its exponent should be in the numerator. So remember that you're just going to move it up to the numerator by changing the power of the exponent. So just to move it up, I'm just going to change the power of 7 to negative 7. It's now in the numerator. Some of you have been moving this number in the front. Just keep in mind that stays in the numerator. There's nothing wrong with the 1 if this was 5 or 7 or whatever it is. It will stay in the numerator because there's nothing wrong with it. There's no x to the 3rd power, and even if there was, it's still in the numerator as we would like before we start the power rule. So, you know, don't flip things. We're not finding reciprocals. We're just making sure we're setting up our problem for the power rule. So now that we have our function for the power rule, we're going to find its derivative. So g prime of x, I'm going to multiply the power times the coefficient. So 1 times negative 7 is negative 7. And remember that the rule states you subtract 1 from the power. So, sidebar here, negative 7 minus 1. I subtract 1 from the power. Remember, if the signs match, you add and take the sign of the bigger number. So the bigger number 7, it's negative, so is your sign. Now, we're not just going to leave it like that because just like the original function, we can't leave a negative exponent in our answer. It's just tacky. It's like leaving a radical in the denominator. We just don't do it. So to clean this up, same rule. Notice that the negative exponent only belongs to the x. If it were in if it were in parentheses, it would belong to both the negative 7 and the x. However, since there's no parentheses, it only belongs to the x. So that is the only one I'm moving to change the power. So this would be x to the 8th power. Again, nothing wrong with the negative 7. It doesn't have a negative power, nothing to change. And there's our derivative. Okay, so I hope this helps. This is just an intro. We're going to step it up a little more as well in the future tutorials. Hope this helps.